Yeah.
Is that good enough?
Yeah, my stuff often fails because there's two screens of different sizes involved.
Okay. You got any problems?
Solve that one. Okay.
Peter.
That's me.
That was me.
And to press on a particular.
How about I drive it for you?
Sorry. Yeah. There we go. Take home message. Which one are you going to go for? You point at what you want, and I'll click on
I
it for
see.
you.
So you right.
Yeah.
All right. We'll start with the take-home message in case I ran out of time. The important part of the take-home message is pjb.com.au, which is where most of the internet happens. In fact, let's have a quick look at pjb.com.au. Very uncertain. Enter.
Click. Do you want me to drive it for you? I'm happy to.
And then down at the bottom there, it should really have auto-sized. Click on computing, and now we're going round in circles. So you might as well click on computing. And that's funny. All right. Okay.
Sorry, I went back.
Oh, you went back. Okay. So look at the take-home message you get. No, don't. Let's not go around in too many circles. And that was the talk at the bottom of computing. So yeah, click on take-home message again. That's because you reloaded it. And I've also left footprints on the face of the internet in gitlab.com/Peter Billum, all one word, no hyphens or anything. And also my lure modules are on lurerox.org, which is where they all are, /modules/Peter Billum, same name, which is what. Let's have a look at the lure modules. Well, they're both interesting, and this is all my lure modules that I wrote and maintain. Some of them are really good. MIDI is important. That's a really great contribution, and MIDI ALSA as well. And there's a read line module, which is and a read key, which is they're both very interesting. And well, they're just basic. You know, and up at the top again, Fluid Synth got an amazing number of downloads, but it's a useful module. Okay, back. Okay, so let's click on Random Fundamentals. This is the touch screen, you see. So I just point the finger at it.
Just like
that. I used to have this. Back in the 1970s, the American Association for Computing Machinery brought out a collection of really neat is not the right word, algorithms that they considered to be important. And it was about 35 mil thick of A4 photocopies. And I was traipsing this lump of paper around with me everywhere across the world for decades. And there was stuff that, all in Fortran 4, almost, for handling sparse matrices and economically and things like that. And it had an algorithm for generating a Gaussian distribution of random numbers. Do people know what a Gaussian distribution is? Okay. So if you measure something and the result should be 500, then on average your measurements will be 500, but there'll be little sort of errors built into your measurement process all the time. So you might actually measure 493 or 501, and the average will be 500. And if you repeat the measurement millions of times and make a histogram, you get this curve, which is the Gaussian distribution. And it's this Carl Friedrich von Gauss who worked out most of maths hundreds of years ago. And it's very important. So if you toss a coin 1,000 times, normally you get 500 heads, 500 tails, if it's a good coin. But that's only on average. On a specific try, you'll get 487, 513. And if you repeat that 1,000 tosses test 1,000,000 times, then the histogram of your results will form this Gaussian distribution. It crops up everywhere in the universe. Gaussian random distributions are just all over the place. They had an algorithm for it, which was ugly.
So you mean the mean of standard
Mean and standard deviation.
The mean of sample means. Give you a bell curve.
In that case, yes.
Yes.
In that example, yes. It's the mean of means. And the standard deviation of those means. Or mean of totals. I don't know.
Well, they'll conform to normal distribution.
There's a normal distribution. That's the other name for it.
Yeah. I've done stats and we all call it
Okay.
normal distribution.
Engineering.
And there's this algorithm for generating random numbers with the Gaussian distribution, which was, I thought, we thought surely it's possible to do it more neatly than that. It was about 2 pages long, 2 columns per page. In Fortran 4, every line had a line number, and there was go-tos all over the place. It was very hard to decipher, and that was called an algorithm. And I carried this around for decades, and eventually I programmed it into Perl when I started using Perl, and that was a brain teaser. I mean, deciphering this old Fortran 4 with just go-tos everywhere. Phew. And it was an ugly algorithm. It had about 10 arrays with about 40 or 50 8-digit numbers, which you had to type in, get every bloody digit right. And I must have gone through those numbers many a time. And I ended up with this algorithm which generated Gaussian distributed numbers. Great. Never really used it. And then eventually I needed to actually use it. It was in PostScript. And I was also starting to write Lua at the time, so I translated it into Lua, which is much easier. And I wrote a little test script, and I ran the test script, and it crashed. I thought, oh no, must have got one of the numbers wrong, so I went all through all the original code again, and all through the go-tos and where they got to, and I couldn't get it to not crash. And eventually I Googled for Gaussian distribution algorithms, and found this really neat website, a much better algorithm, which is this nine lines long. And I couldn't believe it. And he mentioned this Eric somebody, begins with C, at Caltech. He mentioned that the original American Association of Computing Machinery algorithm often crashed. I thought, well, why? I wish someone had told me this 30 years ago, you know. And so I adopted his, and it works perfectly.
So they didn't bother debugging it, they just went and rewrote it.
That's right. Yeah, well, their machines were so slow that they could only generate 10 random numbers in a day, you know. They were like, I don't know. But anyway, this no longer crashes. And so it's very simple. That random ranf gives you a number from 0 to 1. So 2 times ranf gives you a number from 0 to 2. 2 times ranf minus 1 gives you from minus 1 to plus 1. So you've got 2 of these numbers. That gives you a point within the square. And then you just repeat that loop until the point is less than 1 from the origin. While the radius squared is greater than 1, you repeat this loop. So by the time you get out the loop, you've got a random point in a unit circle. And then you apply this magic transform to it, which is where all the magic is, which takes the edge of the circle and smooths it out to infinity, and that gives you a random distribution, Gaussian random distribution. Beautiful algorithm. Why had nobody told me about this before? And so I wrote that up, and that was so tiny in comparison. Okay, back. Then I wrote it up into Lua, translated into PostScript, works beautifully. Let's just have a quick look at the Lua. This is, I eventually put together lots of other random generators in this Lua module called Random Dist. This is very Lua. It's a closure, so there's this function new grand. It generates you a new generator with a specific mean and standard deviation, and you can generate yourself several different generators and run them simultaneously, and they don't tread on each other's toes. And it works beautifully, and it runs fast. The Gaussian, click on that, I forgot what it's called now.
Oh.
Yeah. The Gaussian random ensemble, why did you... Gaussian unitary ensemble, okay. Alright, that's what Wikipedia calls it, don't look that up. This is of no particular relevance, I never used it, but it has very profound meaning. It's the distribution of the eigenvalues of a large Hermitian matrix with random elements. That will interest mathematicians. It's also the distribution of the zeros of the Riemann zeta function, which is colossally important if you're a mathematician, and no one knows why there's that connection. They both then generate the same random distribution. And the mathematician involved was at a conference where he talked to Freeman Dyson, who's a physicist, and he said, what you've been working on? And so, the distribution of the zeros of the random zeta function, they're by this formula here. And Freeman Dyson turned white and his jaw dropped, and he said, well, I've been working on the energy levels of vibrational energy levels of large nuclei, and they're the same formula. And this distribution is very profound somehow. It crops up in these three totally different places, and nobody knows why they're connected. They must arise through the same process or somehow, and that is still not known. But you will never need it, so let's go back. And the Rayleigh distribution is like, if you take a point where the x-axis is a Gaussian random distribution, a normal distribution, and the y-axis is the same, is an independent Gaussian, same standard deviation, an independent Gaussian random distribution, then you get a random point, which is sort of clustered around the origin, but it could also be off to infinity, but it's based on a big cluster of points around the origin. The distance between one of those points and the origin, that obeys the Rayleigh distribution, so it's positive only. So from the origin it climbs steeply and then peaks, and then on the right hand side it tails off to infinity. And that crops up all over in places in physics.
That's a skew.
Sorry?
That's a skew. It's a normal distribution that's skewed.
No, because the normal distribution is goes off to infinity at both ends.
Ah, so it's a t.
And this
t's function.
This plummets to zero at
like
zero.
Like you test it with a t-test.
Yes, possibly. Yeah,
it goes off infinitely.
On the right-hand side.
On the right-hand side, it's a one-tailed test.
And the zero, it just climbs steeply to a peak, and then, but they're closely related because if it's the distance from a random point to the origin.
Course in stats in about a day.
It would crop up in lots of places. I'm sure it would crop up in that.
Yeah, they teach you that shit.
Yeah.
But they call it all different things. To justify their jobs.
And then having done those three, I did a simple one where you just get random get, which gets a random element out of an array. It's useful for being unpredictable. And then a random get n, which is not documented there. I have to do something about that, which gets you n different elements from the array, or with different indices, and the contents, I suppose, can be the same. And that's useful. And then the zip generator. Do people know what the zip distribution is? There's all sorts of things, like if you measure the word frequencies in a natural language, in Esperanto or French or Spanish or English, or in the Shakespeare sonnets or the John Howard's political speeches of the 1980s, or if you measure the word distribution, then you'll get a most common word, and then a second most common word, and a third most common word. And those words are, for a basically unknown reason, always in the proportion of half to a third, to a quarter, to a fifth, to a sixth, to a seventh, to an eighth, the harmonic series it's called, all the way up to infinity. And there's one extra parameter, which is a power that you can raise it to, but which is almost always close to 1. And nobody knows why. And this also is the size of cities in a particular country, like the size of Chinese cities, or the size of cities on the world, or all sorts of other things. The length of rivers, they're all distributed according to zip distribution, even though the mechanisms generating these things are all totally distinct. And there's something very profound in the nature of thingness about the zip distribution, and no one knows what it is. So if you want a Nobel Prize, this is your... and so you can give it a series of words, like here they're all one letters, and then it will generate these words in a proportion of a harmonic series, which might be useful somehow.
You could write a speech for doing that.
You could write speeches or even generate Shakespeare sonnets automatically. Okay, back.
So is "and" a keyword in Lua? I just noticed that "and" is...
Yes, that's right.
Yeah.
Yes, and it's a reserved word.
Cool. Done with that one?
No, before that. Yeah, okay, all right. So we'll look at the postscript. I won't go into this. The same thing except in postscript instead of Lua. Well, a restricted version of it, and then back. And this I've used to actually do work in postscript, which I write postscript in with use of bin vi. This is a diagram that you'll find in Roger Penrose's books all over the place. This is the 3 worlds, he calls it. This is the physical universe, which he, well, being a cosmologist, he understands as consisting of stars and galaxies and stuff. And out of the physical universe arises brains, minds running in those brains. And the process by which the mind arises from the physical contents of the universe is basically mysterious, but they do, and these minds have curiosity, represented by the question marks, and understanding, represented by the exclamation marks. And this process by which those arrive is very non-trivial. Anyway, so that those minds then write down the laws of physics, which is represented by all these mathematical symbols. And the process by which they do that is kind of mysterious as well. And the operation of the laws of physics somehow produce the physical universe. And that is also kind of mysterious. And these things are around in this loop, he calls it the 3 worlds. So that some of these stars have 5 points, some have 6, some have 7, that's a random choice. Their positions are random, I think it was Gaussian around the origin. And whether they're white or yellow is random. And then the brain was hard-coded, but the positions of the exclamations and question marks, they were random, and the choice whether it should be this or that, it was a random choice. And the choice of mathematical symbol in their positions is random. And so there's an enormous amount of... I mean, you could not program by hand the position of all these stars. But you've got a random number generator with various different distributions. It just does it automatically. It's really nice. So it's quite compact postscript that produced that. Okay, backspace. And the woven carpet, these were straight lines, but they were straight lines in sort of, I think it was 20 or 25 straight segments, point to point to point, all the way up from bottom to top. And there were straight lines. And then I Gaussian random the position of the intermediate points, and then draw a smooth curve. And because of random seed, I was then able to run it dozens of times and choose the best one. And then I was able to intervene by hand and force these points to coincide. And the result is but the curves, I just chose the best option. But there's random numbers all through that poster too. So I was very obsessed with doing little postgres with use of invi and PostScript at one stage. It's kind of faded away, but I should get back to it. Okay, so that's random. Markov chains. Do we know what Markov chains are? Markov chains are where you go through a text or text, and then for each sequence of 3 words, let's say, by my understanding, for those 3 words, what's the most likely 4th word? What's the next one which is most likely? And there'll be several possible options, and you note their relative probabilities. And so you just go through a text, could be the sonnets of Beethoven, sonnets of Shakespeare.
Eventually the probability becomes...
Yeah, for each sequence of 3 words that occurs in that, what is the possible next word? Okay, and having done your analysis, you can then turn that loose. So it chooses 3 words at random, and then it chooses one of the possible next 4th words in accordance with their relative probabilities, and then you've got 4 words. So you ignore the first one, output it, then you've got 3. So then you generate the 5th word from the second, third and 4th. And then you throw away the second. And you can generate text which is stylistically authentic, but makes no sense. There's no meaning behind it, but it's stylistically recognisable. You're recognisable. Is that some kind of Shakespeare sonnet? You sure messed up that one. Or speeches by politicians actually come out quite well.
So you can make an algorithm that could generate passwords that are easy to remember.
Yeah.
Oh, well, if you analysed enough passwords, you could certainly get...
Well, I got a random password generator, but I rely on a bank to keep all those motherfuckers in.
Right, yeah.
But the thing is, Markov chains aren't necessarily completely random, so you want something more random than not random.
Okay.
You want someone to be able to reproduce you. I found out which generator is used.
There was a famous use case where a couple of scientists analysed postmodern theoretical papers, university papers in postmodern theory, and they did a Markov chain on that, and they generated random, stylistically conformant but guaranteed totally meaningless postmodern theory, and they submitted that to the world's most prestigious journal of postmodern theory, and all the reviewers were totally enthusiastic about it. And then they wrote a book announcing the hoax, and it did kind of dent postmodern theory. That was kind of the beginning of its downfall within academia. But that's a really good use of a Markov chain. And so I wrote this thing which is not terribly important, but it does generates Markov chains with MIDI. So you can generate, you feed it the the Bach cello suites, and it will generate you a sort of random cello suite, which you can recognise that isn't that a Bach cello suite? Oh, I don't know. Sounds like a jazz soloist improvising Bach cello suites, and basically that's exactly what it is. And you can generate quite listenable music, much more sensible than writing.
Sounds like it's good for identity fraud.
Yeah, it could be.
So all of the ebooks, ebooks Twitter handles are all Markov bots. And sort of what I found interesting is there's a new sort of fad on Mastodon, which is to basically run a Markov bot against yourself, like your main account. So you have, I've got, faulty on Mastodon, so I have faulty ebooks, and it will basically look at all of my tweets and generate new tweets.
Yeah.
May sound like me.
I thought you were going to say there was a bot of bots.
Yeah, you may like to consider
That's
tweeting
how
the
they
following
keep
message,
the
which we know.
Here's a market. I guess it's similar to like Google predictive searches and predictive on your phone. Is it similar sorts of things? Yeah, you type in a word on your phone.
They probably use Markov chains in there somewhere, but theirs will be more complicated.
Well,
But I bet Donald Trump uses it for his tweets,
Yeah, they're based off your specific history, those Markov chains.
They're quite useful, and they're good as a first programming project. Anyway, that's on MIDI. It doesn't handle multi-line music very well. So it's really good on Bach cello suites or Charlie Parker solos, but it's not so good on orchestral pieces. Anyway, back to that's not terribly important. Machine learning, I put a fair amount of time into trying to learn Torch, and those are the tutorials.
Sorry, don't go too quickly.
Yeah, no, they're perfect. You just go down and down and down and down. Each of these tutorials is about an hour. I've got up to 3.4 now, but there's still got a long way to go, and I'm still a long way from being able to write a Hello World application.
right.
It's a very high learning curve at the beginning. Is there anyone in TASLAG that writes in Torch or TensorFlow, the Google equivalent, different language?
I've heard of TensorFlow, I haven't heard
TensorFlow.
of Torch. So Torch is essentially the equivalent.
Well, don't let me discourage you, but it's very hard. It's very hard work. Okay,
Moving on.
back out of that. And yeah, is there a pattern in all this? It's vaguely related. There's random number generators all through this stuff, but I'm not sure why I've gone through this random phase. I think I was aiming at regurgitating, generating my own, because I compose music, so I think I was aimed at kind of automating the composition process, so maybe feed all my previous compositions to Torch and have it pick out common patterns and then feed that into Markov generators and some kind of loop and maybe it would save me all that work, but anyway, that hasn't got very far. But there is some kind of commonality between all this stuff, but I'm not sure what it is yet. For something completely different. How much time have I got?
How much time do you need? You
Oh,
got 5 minutes? Is that
yeah,
enough?
5 minutes.
Yeah, we'll go 5 minutes.
Guitar tablature. Let's have a quick look at. Do people know what guitar tablature is? Okay, when you write normal music, that's it. That's all I want. That's it. When you write normal music, you've got these 5 lines, and you write a particular note, like the pitch that it will sound at, like it's a B flat or an F sharp or whatever. You can write anything like that. You can write for voice, you can write for piano, saxophone, guitar. Guitar is particular, all the classical guitar repertoire is written like that in conventional musical notation. It's quite hard to read on a guitar. The translation from the position of the blobs into which finger goes where is a very non-trivial process. You get the hang of it, but it's hard. And in particular, folk guitarists, by and large, none of them can read guitar music. It is another one of those steep learning curves. What they do is they use tablature, so they use 6 lines, 1 line for each string, and it writes very well in ASCII. And with numbers on the line, and the number tells you which fret you should push down. So you push the 3rd fret on that string, then the 2nd fret on the next string, then you play the G string open, and then play the B string on the 1st fret and the E string open, and that's a C chord. That's the first chord that any aspiring guitarist learns, and it's notated with those numbers, and they're much easier to decipher. So it doesn't tell you what the note was going to be, but it tells you where you should put your fingers in order to make that sound. And that's the notation that all folk guitarists use. And when you use the 10th fret, then you run into this ambiguity. Does it mean 1 followed by 0, or does it mean 10? So they have to put an extra dash between every note. So it doubles the length of the thing. It's quite verbose. So anyway, I got my, back. I transcribed these folk guitar solos from the heroes of my youth, Davy Graham, John Renville, Bert Jansch, Stephen Grossman. We won't have a look at it, but so you can download the A4 score, and this is in musical notation. And I would have killed for this 50 years ago, you know. But folk guitarists don't tend to read musical notation, so I wanted to do a tablature version of it. There you go, so that's musical notation for the guitar. And it's great, it's very specific and it's very helpful, but it's very hard to read. Okay, back. There's 50 pages of that.
But that means you can now play it straight into a MIDI.
Back again. And yeah, so I wrote a tablature version of it, which for that purpose I invented my own tablature, which we'll have to go back again. So that's one of that's Angie. That's what we've just seen.
Not that one. Go back.
Yeah, back from there. And so I wrote.
Guitar tab.
That's too boring. No, back. All right, the last one I shouldn't have put that in. So I wrote my own magic guitar tab notation. It's not standardized in the way that musical notation is. Get that down a bit. Okay, there. And in my notation, there is no intermediate dash between the notes. So if you've got 2 notes like open string and then 2nd fret, one after the other, it's written 0, 2. This means I had to extend the numbers with hexadecimal numbers in order to cover frets 10, 11, 12, 13, 14, 15. And the result is twice as compact, and you can read the rhythm very clearly. And that's the start. We haven't got a loudspeaker here, have we? No, don't worry. I haven't got time. And so that's a G chord with a 3rd fret on the top string, 3rd fret on the bottom string. And this is exactly what folk guitarists like. And that's my guitar tablature of the London. So I wrote this program called, up to the top, Guitar Tab to MIDI, which converts my tablature notation into MIDI that I can listen to. Okay, well that goes on for 2 minutes, I better kill that. Which translates it into MIDI, of which you can hear a bit there, which is great for type reading, for proofreading. So if I do my tablature, I can then listen to the result and say, wrong note, where was that number, fix the number, and it gets you right. So this has got nothing to do with random at all. Okay, back again.
Let it finish.
Okay, well it can jiggle along in the background. Take home message, vjb.com.au is where the internet really hangs out. And I've left my footprints on gitlab.com/peterbillum and luarrocks.org/modules/peterbillum, and that's basically what I wanted to say. So it's a sort of resume of a whole load of stuff that has no particular thread to it, except me. Okay.
Any questions?
Cool.
Any
You happy to
questions?
take questions?
Yeah.
Okay.
You just don't ask me about the formulas for Gaussian random distribution curves and things like that. That was too many decades ago.
Cool. Thanks, Peter.
Okay, thank you.
Wrapping up. Next month, heading back to the pub. So for those that aren't regulars, we do talks every second month.